Bismillahirrahmanirrahim. Let's learn how to write the vector equation of a plane. Before we start writing the equation of a plane, let's see that how can we define a plane or how can we determine the existence of a plane. Okay? देखिए, if you want to understand the equation for plane, you have to see that, like, if this is a line L, okay, a line L can be defined by 2 points on this line. Okay, a line can be defined by 2 points on this line, or in other words, you can also define a line through 1 point on this line and the gradient of this line. Do you agree with this or not? A line can
Yes.
be a line can be described, okay, through 2 points lying on the line, or you can tell its location if you have 1 point on the line and its gradient. Do you agree with this or not?
Yes.
Yes? Okay. Now, coming to the plane. A plane can be defined through three non-collinear points. Now look at this whiteboard over here. These 3 points are lying on this whiteboard. Okay, that is a plane that contains these 3 points. There can be many planes, infinite number of planes which contain this point O, or there can be many planes which contain the points PQ, or the points QR, or the points PR. But there's just one plane in the whole universe which contains these 3 points P, Q, and R. Do you agree with this or not? Yes.
Yes.
Yes. Okay. Secondly, so to define a plane, we need three non-collinear points. Okay, to define a plane, we need three non-collinear plane points. Secondly, if you look at like there's this line AB or the line L, and then there is another line. Let's say this is the line L1. Okay, now these two lines, these two intersecting lines, they are contained by this plane over here. Can there be any other plane which contains both of these two lines, L and L1? Yes, Bacho?
No.
Nahi na? So this is, so it means a plane can also be defined through two intersecting lines. ठीक है, थ्रू टू इंटरसेक्टिंग लाइंस. ठीक है, अच्छा, इसके बाद आगे चलते हैं हम लोग. The thing is that there can be many planes which are parallel to each other. Like if you look at your room, where you're sitting, look at the wall at your right side and the wall at the left side. These two planes, they are parallel, so they will have the same direction, going in the same direction. Okay, look at the ceiling and the floor, they are also going to be parallel to each other. Or like, there is your tabletop that is also parallel to these two planes over here. Okay, so to define a plane, to, like, if you go back to the equation of a vector, which is r is equal to a plus lambda b. So to determine the a certain line in this 3D space, we need to have the position vector of a point on that line. And secondly, we need to have the direction vector parallel to the line or off the line, so that, like, you know that in which direction this line is going. Okay? The direction of a plane is determined by a direction which is normal to this, to that plane we are talking about. Okay. For example, if let me um, ask you, like, suppose there is a bottle uh, lying on the tabletop. Okay, so this bottle is going to be a vertical, like representing a vertical line, है ना? And your table is basically horizontal. Tabletop is horizontal. Yes. Hmm?
Yes.
Yes. So that means the bottle is basically going to determine the direction of your plane, because the bottle is at right angles to the surface of the plane. Okay. So if there is a plane like this, there is a plane like this. Okay. So anything which is at right angles to this. Okay. If I just draw a line on this plane over here, so this is the normal to the plane. You can direct this downwards or you can direct this upwards. Okay. So this normal is basically like a line's direction is determined through the direction which is parallel to that line. Okay. And the direction of a plane is determined through a direction which is perpendicular. Like, this is going to pass through this, like, if this is your n over here. Okay. So this is the n which is normal to this plane. ठीक है? अच्छा. Now, the equation of a plane, how to write the equation of a plane, I'm going to take you there. Let me make some space here. Okay. Acha. The equation of a plane is basically written in the form, like I'll be giving you my method. Okay. I will always start writing the equation of a plane like r dot n, that is equal to a dot n. R dot n is going to be a dot n. Now suppose uh, there is um, like this whiteboard is um, my plane. Okay, here is a point A, here is a point B, here is a point C. Okay, and there are many points over here. Okay, and O is anywhere in this universe. Okay, now imagine this O is not here on this plane. Okay, this can be on the plane as well, but just imagine that O is not right now on the plane. Okay, so suppose here is O somewhere but not on this plane. Okay, so you have, this is your OA, this is your, like, this is your OB. Okay, and this one is your OC over here. Okay, and you can have a point here, this is like, there is OD. So these are all non-collinear points over here. ठीक है? अच्छा, अब बच्चों imagine करो कि here is this line on the plane, that there's a line BC, there is a line AB, there is a line AC. Okay, if there is a normal to the plane like this, suppose there is a normal which is like this onto this plane. Okay, so if I draw that normal over here, this is your n. I draw this normal over here. Okay, this is your n. I draw that normal over here. This is your n. Suppose this is your m, this is your point n, this is your point p over here. What do you think? What should be this n dot the direction vector AB? What should be n dot
Zero.
AB? Yeah,
Zero.
that should be 0. What should be n dot BC? Hmm?
Zero.
That is 0. What is n dot AC? That
Zero.
is 0. So if you understand this, so this is going to be the basis for us to write the equation of a plane, बच्चों. ठीक है? Now let me write down that this n dot AB is going to be equal to 0. Okay? Now, then this, suppose you know this point, one of these points over here. Okay, sorry, both of these points we know them. Okay, now this n dot a, sorry, this should be b minus a, this is b minus a, that is going to be equal to 0. Yes, if this is its direction vector is a, this is going to be b, so your AB would be b minus a, है ना? Your b AB would be b minus a. So this is your n into b minus a, that is going to be equal to 0. Can I write it as n dot b minus n dot a, that is equal to 0? Yes? Yes.
Yes. Yes.
And then this would be nb minus, that should be equal to na. Or you can say that this is b dot n, that is going to be a dot n. Yes or no?
Yes.
Yes? Okay. Now, if I make this be a general point, any point, like, this, as you have this R is any point on your line, okay? So if I change this with, let me call this a point P over here, okay? Let me write instead of this P over here. Oh, what's happening, man? Okay. So this is your, where are they all going?
So you're erasing the white screen you made behind it. इसके ऊपर आप बस like whiteboard बना दें और ये
Okay,
boundary वो भी उठा
let
दें.
me let me go to another page over here. Yeah. Okay, bacho. Now suppose this is your A, this is your P. Okay, we have somewhere over here. This is your OA. Okay, this is A. This is your uh, P, OP, which is R, okay? And this is going to be, this AP is going to be R minus A, okay? And you have here is a normal going on to this, that is your ON, okay? And this is your N over here. So we know that this R minus A dot N, that is going to be equal to 0. This R dot N minus A dot N, that is going to be equal to 0. So this R dot N is going to be A dot N. That is the equation of your plane, which contains these 2 points A, which contains a point A, which has this N as the normal, okay? And this point P is obviously, it is any point on this plane. Okay? So this way we can write down the equation of a plane. Now what information we basically need to write down the equation of a plane? We can be asked to write the equation of a plane if we know three non-collinear points on it. Okay? Or we have one line and one point, the position vector of a point on the line. Or you can have, there are many cases over here basically. You can have two directions parallel to the plane. When I say we need two directions parallel to the plane and one point on the plane, why do we need two directions parallel to the plane?
To do the vector multiplication and get perpendicular.
Wow, very good, mashallah. You know this. Acha. Two directions parallel to the plane and one point on the plane. Okay. Now, when we have one line, one point, or you can have also, you just have two lines on the plane. Okay. So these are some of the cases that you will be given one of these situations and you will be asked to write the equation of the plane. Okay. Now let me go take you back to the exercise. Okay. And we shall take questions from there. Okay. Here is this. Okay.
Sir,
Yes, yes,
अगर
yes.
two lines और plane दी अगर हमें two lines दी होंगी plane के ऊपर, then we'll vector multiply them to find the normal.
Yeah. अभी देखना, अभी आपको सारा कुछ पता लगेगा. Okay. Now the very first situation over here where you are given 3 points on the plane. Okay. Let me just put it here. Let me cover this up. Okay. Now imagine we have these 3 points with us. This is there is a point A which is 2 minus 5 1. There is a point B which is your 0 3 2, and there is a point C which is minus 4 1 1. It's just find the equation of the plane in both vector and Cartesian form. Okay. Now, the thing is, please remember, I always start writing the equation of a plane like this. I tell to myself, okay, look, if you want to have the equation of the plane, you need to, like, this r is going to be xyz, n is the direction vector which is perpendicular to the plane, okay? A is one point, the position vector of a point on the plane, and n is again the normal to the plane, okay? So first of all, this A can be your point A, it can be the point C, it can be the point B. You can use any one of these 3 points as your A. And it's the same as when you were writing the equation of a line. If you have many, many points passing or lying on the line, you can use any one of them for this r equal to a plus lambda b. So any one point, like, there's a line, there are many, many points on this line. Okay, there is this P, Q, R, S. So any point can be your A. Okay. Okay. Then how to find, like, we know that this r is going to be xyz, okay, and then how do we know this n, okay? So you guys have already learned that the cross product of two vectors, okay? So you can have this direction AC, yes, you can have this direction AC. Let me write this quickly. -4 minus 2 is -6, 1 plus 5 is 6, 1 minus 5 is 0, okay? And let's have this direction over here. This is the direction BC, okay? This is -4, 1 minus 3 is -2, and 1 minus 2 is -1, okay? So these are, if you want, you can take this direction as -1, 1, 0. Remember, we can simplify a direction vector. And if you want, you can cancel out all the minuses over here, okay? So the cross product of these two directions will give you your n, okay? So this n is going to be -1, 1, 0 times this 4, 2, 1. And I believe you guys are really good at finding this is 1, okay? And then this is going to be -1. So that is going to be 1. Please keep a check, okay? -2 minus 4 is going to be -6. Is this the normal to the plane? 1, 1 minus 6? Yes, बच्चों है ना?
Want the second? Yeah. Okay.
Okay, so now writing the equation of the plane, it's going to be r dot n is 1, 1 minus 6 dot, so that is equal to a dot n. Which one you want to use as your A, the point A, B, or C? You can use
Second.
any, you can use any one of these points, okay? So this is going to be 2 minus 5, 1 dot this 1, 1 minus 6, okay? So we have here r dot 1, 1 minus 6, that is going to be 2 minus 5 is -3, minus 6 is -9. So this is your equation of the plane in vector form. If you change that r with x, y, z, okay? If you change the r with the x, y, z, so the same equation can be written as x, y, z dot 1, 1 minus 6, that is equal to -9. So this is x plus y minus 6z, that is equal to -9. So this is the equation of the plane in Cartesian form. This was in the vector form. ठीक है? Any questions, बच्चों?
Sir, जब हमने multiplication किया है, cross multiplication किया है of these two lines, so doesn't that generally give us the distance between these two lines, like the shortest distance between them?
That is actually, I will come to it towards
But
the end.
that's skew lines. Yeah, these aren't skew, right? These are like intersecting lines.
Yeah.
So if it's skew lines, then it gives us the shortest distance between those two.
Which?
If we have any two skew lines, कोई भी
हाँ.
दो जो लाइन intersecting और parallel हैं, और हम उनके direction vectors का cross product निकालें, that would give us the shortest distance between those two lines.
No. That will give you a direction
Distance that
which
is
is perpendicular to both of them, beta. Acha, please don't talk about those lines right now. Focus on these planes, the equation of the plane right now. ठीक है?
Okay.
Okay. अच्छा. अभी 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 हम आगे चलते हैं और so this is the situation where you could have 3 points in the plane and then you were supposed to write the equation of the line. ठीक है? अच्छा, अब आगे चलते हैं हम लोग
सर मुझे समझ नहीं आया आपने एंड पे क्या किया है.
where
Sir, why is the dot product is equal to minus 9?
I showed you everything, beta. Like, your story always starts with r dot n that is equal to a dot n. Basically, I was hoping that someone must realize that if you multiply any point on the plane with that n, the result will always be -9. Okay. For example, I have used this point A, you use this point C, you use this point B. This will always be equal to -9. That is basically the definition of of a plane. Basically, we'll come to it maybe later in today's lecture, or I can tell you right now. You see, imagine that my face is that is the origin, okay, right now, and this screen is right in front of me, okay. So I have, like, from my, maybe from my nose, this is OA, this is OC, this is OB, okay. But you see that this normal is a direction, as I showed you in the previous slide, okay. You put that over here as a perpendicular, you put that over here as a perpendicular, you put that over here as a perpendicular, okay. ठीक है ना? So this is always, this dot product is always going to result as a 0. This dot product is always going to result as a 0. Okay. Now imagine that like, where my face is, that is the origin of it. Or like, for example, a few people are, like, sitting, and you have a wall towards your left, okay, and there is a certain distance between you and the wall on your left. Yes or no?
Yes.
Yes. Okay. So if you are the origin there, okay, and you see that the wall on the left and the wall on the right, they are two parallel planes, but they will be determined through the distance between you and the wall. One wall is towards your left, the other is towards the right. Okay. So though we know that what is the direction of the normal to the plane, but another thing which is required, that is the distance of that plane from the origin. As in case of a line, when you have a line over here, okay. So this C is basically, this tells you that how far away is, or where is this line passing through the y-axis. So this is telling us the location of the line. Okay, na? So similarly, look at this. How would you know the location? So this is going to be, n is going to determine the direction of the plane, okay? And this a dot n would tell you that how far away is that plane from the origin. Okay, there would be one more thing added to that, but I want you people to go a bit slow. Okay, first you people learn how to write the equation of the plane, and then we'll come to the debate that why is this and why is that. Okay, right now you need to remember, just try to register in your brains that I'm going to write this again, but show that if you have a line here, this is your A, this is your P, here is the origin, okay, this is your OA, and this one is your, this is your OR, okay. So this AP is going to be R minus A, and here is that normal, okay. This is going to be the point N over here, okay. So your ON dot this AP is basically going to be equal to 0. Through this, you're going to get the equation of the plane. ON is going to be N, and this is going to be R minus A. And through this, you get R dot N, that is going to be A dot N. Just remember this, okay? You need to have the normal to the plane, and you have to have one point on the plane so that you can write the equation of the plane. ठीक है?
Okay, sir. Okay.
अच्छा, अब हम लोग will be moving into the next session, and I'll show you how to write the equation of the plane when you are given, when you're not given 3 points. Maybe you're given two lines of the plane or two directions parallel to the plane and 1 point. So you need to come back for the second session.